Good morning, friends. I am Yashwant Kanetkar, and today I propose to discuss with you how input can be received for a Java program through what are known as command line arguments. Reading input from keyboard, we already know it can be done using the scanner class. But oftentimes you are also required to write programs wherein arguments for the program would be expected through command line. So we must know how to receive input as command line arguments. Now the way to provide these command line arguments would be different for different compilers. For example, if you are trying to run a program straightway on the web by using something like onlinegdb.com, then you will be required to give the command line arguments through this input tab. So first go to the debug tab, within that select input and then give the command line maybe as cat, dog and parrot. So we expect these three to be passed to our program, and we know that any Java program's execution starts with the entry point as main. So these cat, dog and parrot will be passed to our program and would be received by main, and then we can go ahead and process them. Instead of online GDB, if you are making use of maybe an IDE like NetBeans, then you are required to first right click on the project name that you get in the left tab, and from the menu that pops up, select properties. Once you select properties, you will see such a dialog. From here, select run option and then give the arguments as cat, dog and parrot. So that's the way to provide command line arguments if you are using NetBeans as IDE. Instead of NetBeans, maybe you are using some other IDE, then for that some other IDE you would be required to figure out how do you provide the input in the form of command line arguments. So that is something that is going to change from one IDE to another. Processing of command line arguments, however, remains same because that is something which is done within the Java program. So let's see how that can be tackled. Maybe I have a package name called command line args and a public class command line args containing main. And within main, now we will start using this string args array. Into this args array, whatever you provide at command line would get collected. Now if I am to access what has been provided as input for the program through this args array, I have to understand that this array is really an array of string objects. And since it's an array, I can access the elements of that array using the index. So I can very well say that if args contains cat, dog and parrot, then cat will be accessible to me by saying arg0. You can print it out on the screen by saying system.out.println arg0. Likewise, to access dog, you will say args1, and to access parrot, you will say args2. So arg0, args1 and args2 will give me access to cat, dog and parrot as the arguments that have been passed at command line and collected in main in that args array, which is basically an array of string objects. What you should also very carefully observe is that this is an array of string objects, means even if a number is provided at command line, it will be still received as a string. And if received as a string, you will not be able to do any arithmetic on it. What if I wish to do that arithmetic? Well, let's try to understand how that will be tackled. If 400, 210 and 430 are passed, they are also received as strings, as I just now said. And reason why they need to be converted into numbers is the way numbers are stored and the way strings are stored is fundamentally different. For example, if you take a number 210, then when I treat 210 as an integer, what will be stored in memory is its binary equivalent. We know how to obtain binary equivalent. Go on dividing by 2, write remainders, and finally write them in reverse order. If you do so, you will get the binary equivalent of 210. That will be fundamentally different than 210 written within double inverted commas. If within double quotes, then it's treated as a string. And if it is a string, then each character within that string is going to be stored as its Unicode equivalent. So Unicode of 2, Unicode of 1, Unicode of 0, that is what is going to get stored, which will be very different than binary equivalent of 210. That is why if I want to do any arithmetic on these numbers, I need to convert them from their stringized form into their integer or float form before I can carry out those operations. Why don't we write a program which demonstrates how this can be done? Maybe what is provided as command line arguments is principal, number of years and rate of interest. So basically 3 numbers. And we want to perform arithmetic on them to obtain simple interest. If that is the one that I wish to tackle, let's see how it can be done. Start with a package by the name simple interest using command line arguments. Then some public class main, inside which we have the public static void main. Within this we will write the code to convert the stringized numbers into their numeric equivalent. Do realize that the name of this public class can indeed be main. That main you will appreciate is different than this main. You have a capital M here, there is a small case m here. Fine, that is perfectly okay. And assuming that these are the values that were provided as command line arguments, they are available in the form of string because of this double inverted comma. They were not supplied with double inverted comma, they were supplied as 3 numbers, but when received into this args array, they are received as strings. Now to convert them into their numeric equivalent, we need to make use of a ready-made class available in the Java library called float. That float class has got a static method called value of. Method means function. Within this class float, there is a static method called value of. I am calling it and passing to it arg0 means 1000.50. This is what is being passed to arg0. Fine. Once it has been passed, what it returns is a float object. This value of function returns a float object. And then using that object, I am calling a function called float value. The resultant floating point number would be stored in the variable p. Fine. Value of returns a float object. Within that float object, there is a method, there is a function called float value, and that is the one that I am calling. What I want you to observe here is that float is a class. So this is class.method, that's the syntax. Whenever it's class.method, it's always the static method that is being called. Whereas value of will return a float object. That float object dot value of a float value, when I call it's object.method. When I say object.method, it's the instance method. When I say class.method, it means it's a static method. When we do object-oriented programming, it will be amply clear to you as to what really is the difference between a static method and an instance method. Right now, just get used to the syntax. Class.method means it's a static method. Object.method means it's a instance method. On similar lines, I will make use of the integer class present in Java library. Call its method called value of. It will return me an integer object this time. Within that integer object, there is a instance method called int value. It will return me the integer value. I will collect it in n. Likewise, I can convert the rate of interest into some variable r and then get the usual simple interest done. Do define the variables. Finally, you can print the value of simple interest. So that is how you can make use of this float and integer classes to convert a stringized float into a floating point value or a stringized integer into an integer value. This appears to be a little difficult. That is why there is a simpler method available. That simpler method is just a float.parseFloat arg0. Within that float class, there is another static method called parseFloat, to which you provide a string, it returns you the float value from that string. We can collect that in P. So the way we can say float.parseFloat, naturally we will also be able to say integer.parseInt. Now question comes, do I also convert the character by saying character.parseChar? Well, that doesn't work, because for character, if I am to extract the character out of a string, I simply have to make use of a function called char@. Char@0 means get me the character at the 0th position. From a string, I can always extract the character using this char@ function. So string to character you do using char@. String to integer you do using integer.parseInt. String to float you do using float.parseFloat. So this technique you must remember, because oftentimes you would be required to receive input in the form of command line arguments rather than receiving those values as input from keyboard. So input source, if it changes, you can see fundamentally there is a change in the program. So much about how do we go about receiving input in the form of command line arguments. Goodbye and good luck.